Welcome back everyone to Data Science for Everyone. Today we're going to be looking at importing and viewing data in R. Let's get started. So let's first off talk about actually getting data into RStudio Cloud. The first thing that we need to do is go down here to the right hand side here on the lower section, hit the upload button. And we click that, we can actually go through and grab our files. Now this one, it'll only allow you to grab one file at a time. I have two examples here of student debt data. One is a CSV and one is an Excel file. So we'll go on and upload each of those in turn. And to speed up this process, I will be right back doing that. So once you have your files uploaded here, you can see that they are in the project window under the Files tab. Here we have student debt data XLSX, and we also have student debt data .csv. So in order to utilize and import our data, we need to first grab the tidyverse library, and so we can go library tidyverse in here. And if you haven't installed that previously, remember you can do that with the install.packages, and then here is tidyverse. Now I've already installed it, so I'm not going to spend any time doing that, but I will at least have that comment here so you guys can see that up. Now we can grab all different types of data with R, particularly with the tidyverse. If you go through and you can just type in this read underscore. Now look here, you have all of these built-in functions now. These are actually under read R, but you can do CSV, different types of CSV, other delimited types of data. That's maybe sometimes you have, besides CSV is comma separated, sometimes you have TSV, which is tab separated. Sometimes they use semicolons. It just depends on the usually the programmer or anything else, but the two most common types are what we're going to be looking at today, and that is the CSV and the Excel. And that's the next one that we need to look at, and I'll show you over here is we'll talk about importing Excel in a minute, but first let's go on and talk about reading CSV. So let's go on and actually write this up. So we're going to call this data set debt, and I'm going to go on and give it an O or a debt CSV to indicate that I'm importing it from a CSV file. We do read underscore CSV, and then we give it the location of our data. So since I'm in the current working directory, I can actually just start typing in student debt data.csv, and I can run this in here. And if you notice here, there is a lot of information that is kind of popping up in here. Now what happens is this data set, we want to try and figure out, it will try and guess what type of data each of the columns is supposed to be. So it's guessing at, for example here, that there is this a double for this x1. Now this x1 is just an index variable. It believes that the ID should also be a double, so it's some sort of number. The name, address, phone number need to be characters, as well as the company and email name. Now notice here there's a different one right here, and this is the birth date, and it believes it should be some sort of date time format, which is great. Okay, and so we have all of those, and again, some of these, all right, may have, for example, here this that says that there's a missing column name as a warning. It's just telling us that this particular column didn't have a name for it, and so it's just generating X1 for it. And part of this happens because this is just an index column, but I wanted you to be able to see that when we were importing the data. So let's go on and import the Excel file as well in just a second. So I've taken a second to clear out my screen because we were starting to get low in space. So the next thing that we need to do is import the install the packages here, and we need read XL, and this is the package. Again, here it's telling me that I need to restart. I'm going to just tell it that it's okay for now, and it will install that package. Again, if it was already installed, that's fine. So let's go on and do library here, and we do read Excel. Oh, now it's installing. So it'll take it a second. It was just being a little bit slow. And this may take a little bit of time. So I'm going to go on and fast forward through this. Okay, so the data has been properly, not the data, but the library has already been installed, and it is, we have loaded up the library using library read Excel. And so the next thing that we're able to do then is do read Excel. Now notice here, this is now part of the Excel package. Now we can do read Excel, we can do read XLS, we can also do read XLSX, and again, this is just depending on the type of file. You can just about use any of these to read Excel files, but we're going to go on and just use the read Excel file, and I'm going to call this one det_XLSX, and so we are going to read Excel here, and we're going to do student det data.xlsx, and we will run this here, and let's check our data as well. Now notice here it didn't have anything actually come out, so let's actually take a look at the data. Now there are multiple ways to look at the data, as we've seen in the past. Okay, we can just type in this det Excel, and again we could similarly do det_CSV and run this, and you notice that there is this kind of delimited type format. Now one thing that I should notice here, this Excel gives that extra column, this ... one syntax. I personally prefer something like X1, but we can always go through, and when we're cleaning our data, we can drop this row as well. But what it's giving us here is a tibble. Okay, so this is one of the primary ways that we can look at the data. It's a truncated type value, okay, because it doesn't want to show us all of the data. It just gives us the first couple columns and the first 10 rows, and it gives us a little bit of information. So for example, here this table has 1,000 rows and 13 columns, and then it gives us this nice line here that talks about the type of data that it is. Okay, so we see that these first two are doubles, and the rest in that we can see are characters or strings. But then it also tells us that there are 6 more variables and 999 more rows. And then it tells us what each of these are, and again, the birth date in here is a date time object. So this is very useful to take a look at the data. Another thing that you can do, of course, you can always just click on the data, and it will open up the viewer window for you, and here you can actually kind of scroll through and look at the data. If you want, you can even kind of do some filtering and searching as well. So for example, if I want to find I don't know, let's say ID of 60 or something like that, I should be able to actually go in there and change those items and values. But that's kind of besides what we would want to do in the course. Okay, so again, you can see all of the data very well. Similarly, if we want, let me clear this and I will close the viewer. You can also just type in the command line, or in the console here, view, and let's say we want .csv. We hit enter, and notice it will pull up our .csv, and we can scroll through and look at the data as well. So the next thing we need to generally understand is the concept of tidy data. So what we talk about when we talk about tidy data is looking at something a little bit like this. So let me pull in a picture here. So we have our variables, which are in our columns. We have our observations, which are in our rows, and then inside each of the cells we have independent values. Now let's look at this similarly in our data set that we had imported previously. So coming back to our data, we can look at this, and let's look at it first as a tibble. Okay, so again, we can see here we clearly have rows, which are observations. So for example, each of these is an individual student. Okay, oh, by the way, this is fake data, so I'm not giving away anyone's information or anything. So we have our rows, and we also have our columns, and they are nice and neat. Each item in there does have its own unique value. Okay, so we don't have embedded vectors or anything else of the such. And this is the basics of a clean data. And let's go over that one more time, looking and actually viewing our data. So then we can see this in a little bit cleaner format here. Again, we have columns. So for example, we have our name column, our address column, and our phone number column. And then if we go all the way across, we have each individual observation for a person. Okay. And again, you can see, for example, they are unique individuals. And then we also have each individual observation as well. Okay. So, and each individual value. So for example, let's go maybe over to here to age. This particular person's age is 10. This particular person's age is 98. And apparently we also have people that are well over 100 years old in this data set. So again, you can see that we have all of this is in a nice, clean, tabular style data. Now the next thing, once we actually have our data, we need to talk about doing basic summary statistics on the data. So some of the easiest things that we can do when we look at using this is just the summary function, and we actually can just throw in our data set and run this. And notice the first thing that we see here is for each variable itself, we have the variable name, we have the minimum, we have the maximum, and then we have all of the interquartile ranges as well as the mean. So for each of these, now the numerical values are the doubles. Okay, so X and ID, we're able to grab them. Now these aren't necessarily meaningful to us since they are just some generic ID, so they're more of a categorical variable of some sort. But for example, we can look at the age. Okay, so the minimum age apparently is 0, the maximum age is 115, the median age is 57, the mean is 57.32, and again we have our quartiles. Now anything that is a character or a string value doesn't actually get anything. We get the length. So for example, if there's no missing values, we're going to get 1,000 each time here. So that goes for any of the others. Now we also have, which is actually very nice, is in the birth dates, it actually does give us the minimum birthday and the maximum birthday, which is very unique, so that we can actually look at kind of like the spread of dates that we have. And that I do find that to be a very useful trait as well. Okay, I've uploaded a new data set called missingdata.csv, so we can talk about utilizing and how to deal with missing values. So if we look and just import our data, so I'm going to call this a missing. Maybe I want it as missing data, and do read CSV here, and we have our missingdata.csv. We'll run this. Oops, and I need to import the library. So library here is the tidyverse, and then we can do missing data is going to be read CSV, missing data.csv, and again you can see here when we import we have some columns in here. 1 is a double, 2 column 2 is a double, column 3 is a double, column 4 is a character, and column 5 is a logical. So let me go in and clear this out, and we can actually take a look at the data here, and you can see that we have a lot of missing values with this data. So NA, so is not applicable or not. Sometimes you'll see in other languages NaN, so for example maybe not a number, or just missing, it means a missing value. Now we do have a lot of issues when we start to try and run summary statistics. So if we do summary on our missing data, here we run this and it does work. Okay, now it assumes that you are going to ignore the missing values. That's not a problem. Okay, it's always, again, when we're always talking about using the summary function. Okay, if we look at something like we look at the help file in here, so again question mark with the function gives us a help section. Again, it just tells us a little bit about it. So it's going to expect some sort of object. We can do any of the types of numbers and values. So for example, we can control the digits. This is something that we hadn't looked at previously. So let me do that with our missing data. And let's do, again, I'll show you the full. So here you notice here that there are 4 digits in there. And maybe we want to redo this here and do summary, and we'll do missing data. And we want to change this to, let's say, digits is 2. Run this, and notice now it goes and it helps us clean this up and rounds this to 2 digits, which is very useful to us. Now, the next thing that we need to actually look at is if we are dealing with, for example, if we use the mean function on our data. So let's say that we use missing data, and I want to do this on 1. I run this, look what happens. Not applicable, no number. Because what it's trying to do is when we actually use some of the summary, the statistics functions or the aggregation functions, it tries to calculate it with the missing values in there. So to take care of this, we would do mean, let's do our missing data in here, and we want 1 again, and then we want na.rm is equal to true. And we run this, and now we can actually run this data set. So what this na.rm means is to remove the missing values before calculating the statistics, or the statistic or the aggregate function. So we can do this also, for example, if we do maybe standard deviation. If we run this, oh, we don't have that package installed. Hold on. Let me do something like, we'll do median instead and do missing data in here, and we run this again. Oh, we need to do this on numeric data, so 1. So again, it's going to give us this missing value, but again, if we add in the na.rm is equal to true, run this, and it's going to be able to calculate the median for us. So if you guys ever run into an instance where you are running calculating some statistics or calculating something, and it keeps giving you these missing values, make sure and be wary of that, okay? So you need to maybe make sure and do this na.rm is equal to true, because as always, missing values are contagious. Okay, they have a tendency to infect everything if you don't remove them when you're trying to do some sort of calculation with R. If you guys like this video, please make sure and comment, subscribe, and I'll see you guys next time. Bye-bye.